Welcome to the DIY Honda Garage channel. DTC P050D corresponds to a cold start idle speed problem identified in Honda Civic models from 2016 to 2021. This diagnostic trouble code, DTC, is designed to reveal faults in the powertrain control module, PCM, which monitors various engine sensors to maintain optimal performance. Specifically, DTC P050D indicates issues that can cause the engine's idle speed to not meet the required specifications during a cold start situation. This can lead to rough idle or stalling until the engine reaches proper operating temperature. The PCM relies on numerous components, including the mass airflow MAF sensor, the intake air temperature IAT sensor, and the engine coolant temperature ECT sensor, to make real-time adjustments to the engine's idle speed. Understanding this DTC is critical for effective troubleshooting and ensuring the vehicle operates smoothly and efficiently. DTC P050D is specifically related to the cold start idle speed issue, which directly affects the vehicle's drivability. The powertrain control module, PCM, monitors signals from several components, including the engine coolant temperature ECT sensor, mass airflow MAF sensor, and intake air temperature IAT sensor. Each of these sensors plays a crucial role in accurately providing readings to the PCM, allowing it to manage the fuel-air mixture and ensure appropriate idle speeds during cold starts. The ECT sensor is generally located near the engine block, measuring the temperature of the coolant, while the MAF sensor is situated along the intake air duct, converting airflow into a signal for the PCM. The IAT sensor is typically positioned inside the air cleaner housing, where it measures the temperature of the incoming air. A malfunction in any of these components can prompt the DTC P050D alert, leading to performance issues. Several possible causes can trigger DTC P050D, each deserving thorough investigation. Firstly, poor electrical connections in the system can lead to erroneous signals being sent to the PCM, resulting in incorrect adjustments to idle speed. Blockages in the intake air ducts are another potential cause. If airflow is restricted, the engine may not receive sufficient air for proper combustion, negatively impacting idle speed. Additionally, faulty sensors, like a malfunctioning MAF or IAT sensor, can misinform the PCM about the current engine conditions. Lastly, issues with the air cleaner housing or element may hinder airflow and lead to performance degradation. Each suspected issue should be systematically checked and addressed during the troubleshooting process. When DTC P050D is present, several symptoms may manifest. One of the most noticeable signs is a rough engine idle, particularly when the engine is cold. Drivers may experience stalling during cold starts, which can be both inconvenient and concerning. Additionally, there may be an overall decline in acceleration performance, leading to sluggish vehicle response. If the engine struggles to maintain idle speed when cold, it may result in unusual vibrations or even engine shutdown. Understanding these symptoms allows technicians to quickly identify the potential causes of the DTC and implement effective solutions. The first step in troubleshooting DTC P050D involves turning the vehicle to the on mode. This action prepares the vehicle's electrical systems to perform a diagnostic scan. With the Honda Diagnostic System, HDS, technicians should check for any pending or confirmed DTCs. It is imperative to observe whether there are additional DTCs present beyond P050D. If any other pending or confirmed DTCs are indicated, it will be necessary to address those issues separately, as they may be contributing factors to the cold start idle speed problem. Conversely, if no other DTCs are shown, you can proceed to the next troubleshooting step. The second troubleshooting step involves a visual inspection of the intake air duct. This duct is critical as it channels air from outside into the engine. Technicians should check for any poor connections that might impede airflow or for blockages caused by debris or other obstructions. If the duct is found to be in good condition, the technician can move on to the next step in the troubleshooting process. However, if any issues are discovered, reconnect or repair the intake air duct, or replace it entirely if necessary to ensure optimal airflow to the engine. In the third step, a visual inspection of the air cleaner housing is conducted. This housing is vital because it contains the air cleaner element, which filters dirt and debris from incoming air. Technicians should examine the housing to ensure that it has no blockages or loose connections that may affect air intake. If everything appears to be in order, you can proceed to the next step. However, if the inspection reveals issues, the air cleaner housing may need to be replaced to maintain proper air filtration and engine performance. The fourth step focuses on the air cleaner element's condition. This component must be free of dirt and debris to allow unobstructed airflow to the engine. A dirty air cleaner element can significantly detract from engine performance and negatively influence idle behavior during cold starts. If the examination reveals that the air cleaner element is indeed dirty, it must be replaced with a new unit. If the air cleaner element is clean, the technician can move forward to the next step in the troubleshooting process to identify further issues. The fifth step requires letting the engine cool until the value of ECT sensor 1 reads 122 degrees Fahrenheit, 50 degrees Celsius, or less. This ensures that the conditions simulate a true cold start. After the engine has cooled, it is crucial to clear the DTC using the HDS. Then, you will start the engine and let it idle for at least 10 seconds. During this idling period, it's essential to monitor the OBD status for DTC P050D through the DTCs menu on the HDS. If the HDS indicates failed, this suggests that the original failure has been duplicated, guiding you to the next step in the diagnostic process. In the sixth troubleshooting step, a performance check of the MAF sensor is essential. Start the engine and hold the RPM at 3000 without any load, which means the gear should be in park P or neutral N. Keep this RPM level until the radiator fan activates, and then allow the engine to idle. While maintaining a steady RPM of around 2500 for 30 seconds, check key parameters using the HDS. This includes monitoring the MAF sensor's performance against the specified threshold of 4.1 to 5.7 grams per second. If the readings fall within this range, the MAF sensor is functioning correctly, allowing you to move to step 7. The final troubleshooting step involves checking the performance of IAT sensor 1. First, turn the vehicle to off lock mode and allow the engine to cool down to ambient temperature. Make a note of what this ambient temperature is. After that, turn the vehicle back to on mode and quickly note the value recorded by IAT sensor 1 using the HDS. This value should be compared against the previously noted ambient temperature. If there is a difference of 5.4 degrees Fahrenheit or more, it indicates a malfunctioning IAT sensor or MAF sensor, necessitating replacement. If the IAT sensor is found to be functioning correctly, check the throttle bore for dirt, carbon, or damage, cleaning or replacing as required. Once all necessary repairs and replacements have been performed, it is vital to conduct a final repair verification. This involves test driving the vehicle under conditions similar to the initial complaint to verify that the idle speed is now operating correctly. It's important to pay close attention to how the vehicle behaves during cold starts. ensuring that the rough idle and stalling issues are resolved. During this process, continually monitor for any reappearance of DTC P050D using the HDS. Confirming that the error code does not return will affirm the success of the troubleshooting and repair efforts. To prevent the reoccurrence of DTC P050D, proactive and regular maintenance is essential. Begin by routinely checking and replacing air filters to ensure optimal airflow and engine performance. It's also crucial to inspect the entire intake system, including air ducts, to ensure there are no blockages or leaks that can affect air intake. Additionally, regularly monitor the performance of key sensors like the MAF and IAT sensors to catch any issues before they lead to serious problems. Implementing these preventive maintenance practices can greatly enhance the longevity of the vehicle's engine system and ensure smooth operation during cold starts. In conclusion, DTC P050D, indicating a cold start idle speed problem, is a significant issue that requires careful attention. The role of various sensors, such as the MAF and IAT sensors, is crucial for the PCM to accurately manage the engine's performance, particularly during cold starts. The troubleshooting steps must be followed systematically to effectively identify and address the root causes of the DTC. By ensuring that each component is inspected and functioning as intended, technicians can resolve this issue and prevent future occurrences. Adopting preventive maintenance measures will further safeguard the engine's efficiency and health, leading to better reliability for the Honda Civic models 2016 to 2021. Please like and subscribe to the channel. See you next time.